What is a macro? As we discussed earlier, macro is a method to create modules in the program. A module represents a specific action. It will have a purpose. And when we create modules, it will be a sequence of instructions. We can assign a name also to a macro. So if we create a macro, name of the macro may appear once or several times depending upon the requirement in the main program. That's how a macro is created and used. Now, when we create a macro, we can say that a macro will have a name, it may have a set of formal parameters, and it will have the body of macro also. By body of macro, we mean that the statements within the macro. Name of the macro identifies those statements. What are parameters? Parameters are a way to communicate between the main program and subprograms. Programs communicate each other using parameters. So parameters can be used in macros also. Now, how a macro is getting executed? In a macro will be having a name and formal parameters. What will happen in a macro is, macro is a method to create modules that we have learned. And when we have to relate this with functions. If you have learned a programming language like CPP or say Java, you will use functions. So we know that even functions are used for creating modules. What will happen when a function is getting created, and what will happen when we execute our program with that function? So unlike in a function, a macro name with a set of parameters will be replaced by the set of statements existing in the body of the macro. And this is called as macro expansion. I will explain you in the coming class with an example how the expansion will go on. See here, you can see a narration regarding a comparative chart about macro versus function. How a macro and function differs. So you can see that, what's common in macros. What is common is that both macro and functions are methods to realize modules. Macro is also a set of statements. Macro will represent a sequence of instructions. Function also represents a sequence of instructions. Wherever those sequence of instructions are required in our main program, then instead of repeating those statements again, we will use the name of a function or a macro. That is similarity. Hence, macro, we can say that it is a set of instructions, a sequence of instructions within the macro definition. And what about function? There are methods for defining a function and calling for a function. So within those function headers, the body of the function will happen. Name of the function, data type of the function, parameters, if any, everything will be specified. And within that, our code will be embedded. And that is how macro and function is getting defined. Macro requires more memory and procedures requires less memory. Now, instead of reading these obvious things, I would like to pinpoint on one fact: how a function is treated in the compilation process and how a macro is treated when the program is getting actually interpreted, translated, or compiled. Suppose that we write a function for a purpose. Suppose that we have a main program and subprogram. Main and subprogram. Main and subprogram, when we make use, we know that wherever the sub is required, SUB, name of the subprogram, will be added in the main program wherever required. If sub is having a return value, we may or may not make use of return value depending upon the context. But whenever we make use of name of the function in our program, there is no replacement. Function name will not be replaced by the entire body of the function. What do you mean by body of the function? Body of the function is the statements that consist of the function. That won't be substituted with the function name. Whereas a jump will be made to the body of the function during the execution time, and as soon as a return statement is encountered, control will be transferred to main program again. That is how flow of control happens when you have a function call. Main program will be getting executed. Suppose that from the 6th line onwards, there was a function call. So it is from the 6th line in the main program, you say you make a function, say prime, your prime function. From that point onward, program counter will be loaded with the first address of the instruction in the prime function, and temporarily control will be transferred to main function. Once the return statement is encountered in the main function, then the main function will be resumed from the point where it was stopped temporarily. This is the practice in functions. Whereas when we make use of macros, there is a process called as macro processing. There is a macro processor. This macro processor does a pure substitution work. Whenever we write a macro and when we use that, before our assembly program or even our C program or CPP program, which is having macros, before it is subject to the process of translation, each macro will be substituted. Each macro will be substituted with the statements within the corresponding macro. That means if I have a macro called as say MAC1, and this MAC1, if it is having say 10 statements, and if we had used MAC1 say in 10 places in our main program, before the main program is getting translated, every instance of MAC1 will be replaced with those 10 statements. That is how macro is getting treated. So the name of the macro will not appear in our source code when the program is getting actually translated. And that is meant by the pre-processing step. And that is the fundamental difference between a macro and a function. The way how they are treated during the translation process and how the program is getting executed. So I repeat that macro instructions in the macro will become part of the actual code itself before it is getting translated. Replacing the name of the macro with the corresponding instructions in the macro is called as macro expansion. Macro processor. So we told about the substitution. Each macro name will be substituted or replaced with the set of instructions that are added with a macro. And here we can see that it is a pure replacement, text replacement. What we have done inside a macro will not be looked up. That's the job of the assembler in the actual translation process. So a macro processor will just substitute our macros with the set of instructions. Hence, we say that job of a macro processor is machine or device independent. It's only a text replacement. Now, what are all the fundamental operations of a macro processor? We can define a macro. We can call a macro. Calling a macro is called as invoking a macro also. When you call a function, you can say you are invoking a function call, macro call. Third one is expanding a macro. Now, how can you define a macro? We know that now we know how to define a function. Please don't tell me that you don't remember that. And I'm afraid to ask you questions also. We are in a serious situation now. You leave out of Google Classroom when you are asked questions. Even if you are asked questions without any ledger, you say that I don't remember and I don't know. Even those things that you know, we are in a very serious situation now. Okay, it's up to you to correct this. A function, when we define a function, we know that a function, say in C programming language, a function, we will have a prototype in the beginning. Prototype will be having the return value of the function, if at all, otherwise we'll say void. Then we'll add the name of the function. If the function is having any parameters within brackets, we will give a comma separated list of the arguments. Say we have written a prime function. We accept integer as the argument. Suppose the return another integer, so it will be int prime within bracket int. That's it. Later, we will add the actual function definition. When we add the actual function definition in the main, as part of the main program, we will be having a function header. We say int prime within bracket again int. Then we specifically add an argument name. Then we will start the body of the function. Similarly, when we write a macro starts with a pseudo opcode called as macro. And macro, immediately after this instruction called as macro, we will add INCR. INCR is a name of the macro. It can be anything. You can add your own name also. So after a macro pseudo opcode, this statement will be immediately followed by the name of the macro. Once the name of the macro is specified, it is followed by a set of statements, a sequence of instructions, and that is called as the body of the macro. Once the body of the macro is OR, we will add MEND, M-E-N-D state keyword. No, it's a pseudo opcode. So the actual macro will be sandwiched between macro and MEND. Last statement of a macro will be always MEND, MEND. Within macro and MEND statements, we have this macro, and that too the first line will be the name of the macro. This is how do we define a macro. And exact definitions of this, exact methods of this, of course, it may vary from assembler to assembler. Some assemblers will also allow you to add INCR along with macro. It depends upon as an assembler. We take a generic case. Here we have an example. See, macro is the first statement. That means now the assembler will know that the following code represents a macro definition. After macro, INCR is a name of the macro. Then we have the actual statements here. See, add one data. What do you mean by one? One represents a register, R1. Contents of data is added to 1. And the result is kept back in 1. There are two semantics of add 1 to is 2. First, value stored in data will be accessed. It will be added to the value in 1. And whatever the result will be kept in 1 itself. Similarly, add 2 and add 3. Mend macro, it specifies the end of the macro. So this is how we define our macros. So here you can see that we have to also add what is meant by data. So we have to add the pseudo instructions for defining data also, as you had done in assembly language programming days. Due to this part, we have not added in the example here. Remember that. It has to be there. Once we define a macro, we can call our macro. So once we define a function, initially we'll add a prototype. We will define a function. Once a function is defined, the body of the function will remain dormant in our code till we explicitly call it. So if prime is our function, till we say we'll call prime won't be executed. Similarly, till we call a macro won't be executed. Now, how to call a macro? Macro will be called by adding its name wherever its operation is required. Suppose that you want to do these 3 additions. Wherever you want to add these 3 values, to do these 3 add statements, in all those instances, we have to call the name of the macro. That is meant by calling macro. Now, how many times a macro can be called? It depends upon the context. It depends upon the logic we have written. Hence, we can say that the occurrence of a macro name outside the macro definition part is called as a macro call. So here you can see that even if INCR appears here, we cannot say that INCR is a macro call. Why? Since ISCR appeared immediately after the macro pseudo opcode, it represents the name of the macro. Here we are defining the macro. So in this code segment, macro INCR is defined. It is not yet called. To call this macro, we will add INCR again here somewhere after this macro definition. See this example here. This is the first part that we had seen earlier. Macro INCR is defined. Now we call macro somewhere in the source code. See, INCR macro is called, and INCR is called several times. We may call several times. We may not call also. Depends upon our requirement. See, data is defined in the last part. Data DCF5. So it's a literal value. Data represents a literal value, and the code goes like this. So this piece of code, assembly code segment, it has a macro and a macro, and this say macro called INCR is called 3 times. Now, how this expansion occurs? So as I'm telling continuously, unlike a function, wherever a macro name occurs, see here we have INCR 3 times. Wherever before this statement is getting translated, assembled, each occurrence of INCR will be replaced with 3 add statements. That is how the macro is getting processed. It says substitution, mere substitution, text substitution work. And this work is done by the macro processor. How it will know that INCR is a macro? Because of this keyword, macro and mend. Immediately after macro, name of the macro is expected. Once this macro name is appearing in any part of the code, INCR can be merely replaced with, say, 3 add statements. So these 3 add statements will appear thrice before the code is getting assembled. INCR will be removed. Instead of INCR, these statements will be added. And that is how this process is called as macro expansion. So we can say that name of the macro will not appear in the source code after this process. I hope things are fine with you and you can follow, understand what I say. Like functions, even macro can have arguments. How arguments can be added? Arguments, what is the use of arguments? And how arguments can be used? Arguments can be used along with the macro name. Immediately after the name of the macro, we can provide a comma separated list of arguments. If we have multiple arguments, each arguments will be separated by a comma. And each name of the argument will be preceded with an ampersand character. So the 2 requirements we have to do. Arguments will be added, preceded. If X is an argument, ampersand X will appear in the code. And such arguments are called dummy arguments. Again, this can be a question. What about explain about dummy arguments? See here, same macro, we have added an argument here, arg. You can see that arg is preceded with the ampersand character here. Arg is an argument. And here, now, if you compare, you can see here that here data value is hard-coded. We hard-code a constant here. Suppose that value, we want to add any value that we supply to registers 1 and 2, 3. Then this design has to change. Here, the value getting added is hard-coded. It is fixed. Till we can change here, of course, and this same value will be getting added here. If this part can be made as an argument, we can supply the value to be added along with the macro call, and that is being done here. See, we have created an argument here, and that argument is appearing in the body of the macro again. Add 1 ampersand arg. So we add the value supplied by the argument with the registers here. And this is how we can define a macro with arguments. Here we make use of only a single argument. How this macro can be called? See, first time we call with data1. Now we have 2 literals, data1 and data2 with different values. If we say INCR data1, so data1 is the argument here. You can see the difference between a macro call and a macro definition when there are arguments. In the macro definition, we will add the macro name with ampersand character. Whereas when we actually call it, ampersand character won't be there. This character, instead of this, the actual argument will be added. So INCR data1. Here the second call comes INCR data2. Here data1 replaces arg. in the body of the code. Now, how this will be, how INCR data 1 will be replaced? How? Macro can have, before we get into that, we'll see how it will be replaced. See, INCR data 1, when we make use of INCR data 1, how the processing will go? We know that INCR data 1 will be subjected to macro expansion. Now, how it will be expanded? Here, in this instance of INCR data 1 will be add 1 data 1, add 2 comma data 1, add 3 data 1. When you say INCR data 2, this single statement will be replaced with add 1 comma data 2. So we have now, we supply even the value to be added. This is how we can use single argument to a function, and how this function can, macro, and how this macro can be invoked, and how the macro will be expanded. Suppose that we have multiple arguments. If we have multiple arguments, we will supply a comma separated list of arguments. See here, now the same function macro we have modified. Macro, name of the macro. Here you have this name of the macro. Macro pseudo opcode indicate beginning of a macro. INCR's name of the macro, we have 3 arguments now. arg1, arg2, arg3. Here we make use of 3 values. That means 3 values are getting passed to this macro from the main program. 3 values. And these 3 different values are getting added to 3 registers. And how will you call them? INCR data 1, data 2, data 3. Of course, you should have these literal definitions in the source code. So after this macro call, this is the place where we have defined our macro. Now we'll have to call this macro. How to call? When you call the macro, we will add a comma separated list of arguments. Each argument will be replaced with the argument name in the body of the macro. So since INCR data 1, so data 1 corresponds to arg1. This is how things are getting matched. Data 2 will replace arg2. Data 3 will replace arg3 in the source code. So when you expand this, how things will, how can you expand this? See, INCR, you may call INCR now. How this can be expanded? If you have a pen with you, you can just try writing this down. INCR, add 1 data 1, add 2 data 2, add 3 data 3, this instance. Here, the same macro is used with a different order of parameters. So this will be add 1 data 3, add 2 data 2, and add 3 data 1. This is how we can make use of arguments, multiple arguments with the same macro. Now let us take one more example for passing arguments. See here, we have one more argument. This is highlighted because this argument, you can see it happens here. It is on the label field. We know that in an assembly language statement, there are fields. There are fields for even labels. There is a place where the label has to occur. So you can see that lab is a label. So even a label can be an argument. So we have in the same code, we have 4 arguments, arg1, arg2, and arg3. Values of arg1, arg2, and arg3 will be added with registers 1, 2, and 3 respectively. I hope it is clear. Registers 1, 2, 3 will be added with the values of R1, R2, and R3 respectively. What about lab? Lab represents a label. It indicates the beginning of this code. Now we'll see how, let us see how this macro can be called. So when you call this macro, we can say incr, and we have 4 arguments. See, data 1, data 2, data 3, and loop 1. Here, data 1 corresponds to arg1, data 2 corresponds to arg2, and data 3 corresponds to arg3. We have loop 1 that corresponds to lab. It's an actual label. How this INC first increment, first statement will be expanded? You can see that it will be expanded as follows. See, instead of see add, first statement is add. So add 1 data 1. arg1 is replaced by data 1. arg2 is replaced by data 2. arg3 by data 3 respectively. That's clear. What about lab? You can see that for label it is loop 1. Loop 1 is replaced by this argument. Now how this same thing will be done with this statement? I hope you can say that. Loop 2 will come here. See, loop 2. Lab will be replaced by loop 2. Again, add 1 data 3, add 2 data 2, add 3 data 1. This is how it will be expanded. So today we just started our discussion on macros. We now know what is meant by a macro, what's the purpose of a macro, how it differs from a function in 3 aspects. How a function is getting defined, how a function is getting declared, how a function is getting called. Finally, how a function is getting executed. We know this. We know the other part also. Now, how a function is getting defined, how a function is getting called, and what is the process that is specially applied on a macro before the assembly process starts. We also learned about arguments in a macro, how to add arguments in a macro, and how to add multiple arguments to a macro, and how a macro will be defined with no arguments, with just one argument, with multiple arguments. Finally, how to call a macro and how this instance of macro calls will be substituted with actual body of the macro, which is called as macro expansion.